Okay, class, let's take a look at 12, 13, and 14 for this video. We can definitely see on the first one is it's saying graph the solution of the following inequality. Inequality, remember, is just the greater than or equal to, or less than or equal to. And so here we find ourselves at a very fortunate place, and that this is already factored for us. If it wasn't factored for us, you would need to factor it in order to get your critical values. So again, I believe this is coming from your test 4, and you were graphing these inequalities. And so let's take a quick look at when we solve each of these, what values do we get? So in this case, we get x equals 0, and we get x equals a positive 6. Now you might be thinking, okay, how did that happen? Remember, x minus 6 equals 0, add 6 to both sides, and you'd have x equals 6. And so these are what we call our critical values. Those are extremely important here. And now notice also that the inequality sign is less than. That's going to become really important, but there's no line underneath. So in this case, we would use open dots at these two critical values. Of course, you could put it on there, or you could put it above. It doesn't really matter. Sometimes you would have also potentially seen this as parentheses, but since we're not sure of what direction the parentheses will be in, we just typically use open circle. So now what do we have to do to determine what region or what area will be sufficient here? And we do what's called test points, and notice I switched colors to a red to do my test point. So I'm going to choose pretty easy values to do quick computation, and I'm going to choose -10. Over here, I'm probably going to choose something like 5 because that's easy. And then I'll probably choose positive 10. So what do we call these? We call these like test points. We're testing them to see what happens when we plug those in. It's representing that whole region, so to speak. And so let's try our first one. So this would say -10, parentheses, -10 minus 6 is supposedly less than 0. That's what we're testing. So we have -10 times -16 is less than, not equal to, let me erase that really quick, is less than 0. Well, we know that when we plug that in, -10 times negative, that would give me a positive, and a positive is definitely not less than 0, so that's not true. So we're not going to shade there. Do not shade. So it did not pass. So now I'm going to take the test point of 5, and I'm going to do that exact same dance. I'll do it up here so we have a little bit more space. I have 5, open parentheses, 5 minus 6 is less than 0. So then that would be 5 times a -1 is less than 0. A positive times a negative, so our -5. A negative is less than 0, so we are definitely going to shade in this area. Now the last little test point is this 10. And so we would have, but we also know quadratics are symmetrical. If we wanted to visually see this, you could put this into Desmos and see how cool this is, that essentially this is where our graph would be true at. So 10, so this would be 10 times 10 minus 6 is less than 0. Again, that's what we're testing. 10 minus 6 would give me +4 is less than 0, and you get a positive is not less than 0. So this is not true either. So we can confidently say that our solutions, or the area that would make this inequality true, has to live in between 0 and 6. And so that would be our answer shaded on a graph. Now let's take a look at number 13. It's asking us to solve for V. I'm going to switch colors here just so it's easier for us to work on a different problem with. And it says solve for V, but V is trapped underneath both of these radical signs, are square roots. So all we have to do to free it is simply square both sides. The root, the square root, and the power of 2 cancel each other out. And so we're left with 6v minus 4 equals 9v minus 16. And now we can easily manipulate this and go back to what we did in week 1, which was solving linear equations. And so I'm going to subtract 9v from both sides. So that would give me -3v minus 4 equals -16. Now I'm going to add 4 to both sides, and I get -3v equals -12. I'm going to divide both sides by -3. and I end up with v equals positive 4. Of course, it's important that you check your work here because this could be what's called an extraneous solution, or it doesn't make it true. So you do want to stop and make sure you check your work here. So I'm going to just check it. Checking it simply means every place you had a v in the original problem, you are now going to put it into the equation. So 6 times 4 minus 4 should equal the same as the square root of 9 times 4 minus 16. And so let's see if that's true. So this would be 24 minus 4, the square root of 20. It should be the same as, that would be 36 minus 16, and I get the square root of 20, and they do equal each other. So I can say confidently that our answer is v equals 4. I don't have to reject it or say no solution. The next one we're looking at is graphing a rational function, or a polynomial over a polynomial. And this is kind of interesting in the sense that we definitely can leverage technology, which we are, but I'm definitely going to kind of do a quick review over some things that we would have learned in the rational function unit, just to make sure that you are prepared for whatever could come your way on this particular problem. So the first thing we want to figure out is what is our domain restrictions, or our vertical asymptotes. And then we'll look for horizontal asymptotes, and that will kind of help to usher in the next phase of this. So that we can have plenty of space here, I'm definitely going to erase some of this prior work so it doesn't get in our way, and so we can start looking at this problem. I definitely want you first to start by setting your denominator, or what we call our domain restriction. I want us to set that equal to 0 and solve. So that would be negative 2x minus 1 equals 0. So plus 1, negative 2x equals positive 1 divided by 2 divided by 2. And we get x equals negative 1/2. What does this really mean? Well, this is our vertical asymptote, or our barrier, or force field that we cannot cross. So it's a little hard to see here. I wonder if I can even make it big. I think I can. So that would be somewhere right in here at negative 1/2. So we would have something like, it's a little tricky. So there's our kind of imaginary force field. And we're going to do the exact same thing with horizontal asymptotes, but for horizontal asymptotes, let me switch to red. We have to look at our degrees of our numerator and denominator, and since our degrees are the same, we just have to look at the numerical coefficients in front here to determine what our horizontal asymptote would always be. The number fraction, it happens to also be negative 1/2. So this would be y equals negative 1/2 is our horizontal asymptote. So again, we come back over to our graph, and we graph that at negative 1/2, and now we have an imaginary force field that's somewhere right in here, and again, kind of difficult to see. So essentially that's our force field that it cannot cross. The next thing we want to kind of look at is, well, what is our x and y intercepts? Again, this is going to kind of help give it shape and give it some substance. And so to figure out your x-intercept, we set our y equal to 0. So that would be y equals x plus 2 divided by negative 2x minus 1. And we would set this to 0. So I'm just going to quickly erase this and make this 0 equals. And now we're solving for x. Again, there's a few different ways that we can do this, but most people would think to cross multiply, and 0 times anything gives me 0. So it's essentially 0 equals x plus 2. Or you could have just multiplied both sides by your LCD like we did in a prior video. And in both cases, 0 cancels that out, and we're left with this. And so we get negative 2 equals x, and our x-intercept is negative 2, 0. So we're going to have the x-intercept in this region. And now we need to figure out what is our y value, our y-intercept. And again, that same song and dance holds true. I'll do it down here. Let me get a different color here. Let's do yellow for y-intercept. you would set x equal to 0 and solve. So we'd have y equals 0 plus 2 over negative 2 times 0. Too many parentheses on that one. 0 minus 1. We would get 2 over negative 1 or negative 2. So my y-intercept would be when my x is 0, I get negative 2. So I would come put that point over here at negative 2. So ultimately what we can determine, and of course you might want to get another, another few points, but we start to see something that looks like ultimately I would feel like this is helpful and good for you to know, but we definitely want to figure out what it is in Desmos. So again, kind of like what I did last time, I went ahead and pre-programmed it into Desmos, and you can see that we have our ordered pairs of 0, negative 2, and negative 2, comma 0. And we get a very similar image as like our sketch. Now I will tell you, be cautious, because it's very easy to get excited about Desmos doing this, but if you violate and cross over those horizontal asymptotes and the vertical asymptote, it will count it as wrong. So definitely have your guard up with the asymptotes. So you still want to keep track of how to determine your asymptotes.